Our last panelist is Dr. David Dilts. He's the managing partner for Dilts & Partners, LLC. He's also adjunct professor of management at both Owen Graduate School of Management at Vanderbilt and the Division of Healthcare Management at Oregon Health and Science University. Please join me in welcoming Dr. Dilts.
Thank you. Okay, I am the antithesis of the lawyers. Not only do I not like sitting, I don't like standing behind a podium. Because I teach M.B.As, and if they know where you're at, they go to sleep. All right? So I'm going to wander. All right? I have got 90 slides in 10 minutes. So you ready? We're going to go quickly. Everything I'm going to talk about, if you want more information about it, it's all published. I can give you citations, and God love you. The other thing about this is they always put me at the end of the day, which means I'm between you and the bar. So I'm going to be quick. All right. So this is what we're supposed to do. We're to examine the ways to improve efficiency and lower the cost of clinical trials and other costly phases of drug development. I'm going to tell you 4 things. Number 1 is you're looking at the wrong things. Everything you talked about today is okay, but you're looking at the wrong things. Number 2 is the amount of variance among each of the processes is insane, which as a systems engineer tells me the entire process is out of control. Okay? So fixing one part is not going to make any difference at all, and I will show you real data about that. The last one is let's work together. You know where barcodes came from? Barcodes came from IBM. They gave it away. Why? Because we want to sell a lot of computers. Anybody use USB? Right? This is a consortium. These guys put this together because Intel said, this is not how we make money. This is what NIH, this is what NCATS needs to work on, is these things rather than on specific drugs, because that's where you get the bang for the buck. Okay? All right. And particularly Chris, I told Chris I'm going to pick on him a little bit. I have developed technology roadmaps for other industries, including heavy manufacturing, and I'll show you some of the things you might not know that you can do with it, which is really kind of clever. Okay, that wasn't my idea, it was somebody else's idea. It was really clever. So number 1, this is the pipeline, as you've seen today. This is how I see it. Okay, we have all this flow, and I'm like, no, man, there's all kinds of squirting and draining. I mean, it is a mess. I actually give a talk that says, you remind me of Oldsmobile in 1980. A, there's no more Oldsmobile, and B, this was before the Japanese came and cleaned our clock in the U.S. automotive industry. All right? My thing is, one of the things we ought to do is encourage competition that would make everybody more efficient. All right. Basically, the research waste is a scandal. Huge sums of money are spent annually on research that is seriously flawed through the use of inappropriate designs, unrepresentative sample size, small samples, incorrect methods of analysis, and faulty interpretation, and I've got more. Okay, so hang on, I got more. I was having fun as an engineer, and by the way, engineering, NIH, not invented here. Okay? It's like I had no idea what it was. And an oncologist called me and said, oh my goodness, the NIH is going to give you a lot of money to look at accruals because we've got a problem with accruals in cancer. And I said, okay, I have no idea. So I said, map out what it takes from the time you have an idea all the way until the time you close the trial. And I found a really interesting thing. Right in the middle is when you open the trial. Now, when you look at the research and look at the things that people talk about, it's all about what do you do once we get the trial open, and nobody talked about how to get ready. By the way, this is how the Japanese beat General Motors, Ford, and Chrysler, because once General Motors, Ford, and Chrysler got ready to work, they could beat anyone on the planet, but it took them forever to get ready to work. If any of you have teenagers, how long does it take them to get ready to study? Right? Is getting ready to study an important issue? This is a phase 3 clinical trial. The answer is abso-friggin-lutely. It takes just as much time to open it as it takes to run it. So when you talk about it takes 12 years to do, you're not even including the years before. You're not even counting that. Okay? So that's one leakage. When you do a clinical trial in oncology, you typically work with a cooperative group who then has to go to the cancer therapy evaluation program, and then you go to your local, basically, academic medical center. All right? At the high level, cool. We have an idea, concept, we build it, we get the forms, we do all this compliance, we do the grants, we talk regulatory affairs, we go to centralized IRB and get it approved. Really cool, except when you really drill down, this is a process map 50 feet long by 5 feet in 8-point font. Okay? This is a cooperative group, but cooperative groups cannot open studies. They have to go through CTEP, which is another process map, which is 45 feet long by 5 feet, 8-point font. And I still can't open it at my academic medical center because I have all the lawyers and everybody else at my academic medical center, and they're going to take another 37 feet. right? Somebody wrote a critique of my article, and they said, it's an ordinary miracle of phase 3 clinical trials. It's a miracle anybody ever gets it done. It's just a miracle, okay? So is it a game of chutes and ladders? We go so far, or is it like this, right? Everybody's really busy, but is anything getting out of the system? No, but everybody's really busy. Okay. When you actually count the steps, I'm not going to count all the steps, but I am going to call you and your boss who said, I can always find a change in the contract. That's a loop, okay? Basically, loop says we're going to go back into the system and do it again. Every time you loop, the problem with the loop is it takes more time. And I'm going to show you in just a second what does time mean to oncology clinical trials, because it means a lot. By the way, 36 separate groups or individuals has to approve a phase 3 clinical trial sponsored by the NCI. That's insane. Imagine doing basic research. You can't do any experiment until 36 separate people say, yes, you can do that. Right? That's just ridiculous. Okay. We can lick gravity, but sometimes the paperwork is overwhelming. It just takes way too long. How long does it actually take? The median time to go through this thing is 2.5 years. That's not the problem. The problem is I can open a trial a little over a year or a little under 7 years. And I said, wow, that's a lot. And I told you, oh, no, I'm going to pick on you. Jennifer, what's the difference between a trial that took a little over a year and a little over 7 years? And your answer is, honest to God, how many trials do you run? I mean, they've run hundreds of trials and have zero idea why some would take a year, some would take 7 years. If you don't even understand that, your system is out of control, period. Okay? Now, by the way, this is just general statistics to show you know how to do plots. Unexpectedly, we talked to a cooperative group, and they said, just give me your accrual rates. Everybody's heard the problem with accruals for clinical trials. It's bad, it's abysmal, it's whatever. And we said, really simply, the blue studies opened faster than the median, and the red studies took longer than the median. And you know what we found out? We found out that time makes a difference to accruals. A significant difference to accruals. If it takes too long, nobody's going to show up to the study. Ladies and gentlemen, you are a fashion industry. That means that you better have stuff going really fast because it's fashionable right now. Fashionable in oncology is immunotherapy, right? And I know something else is going to be fashionable in about 10 years, and it's a fashion, which means you better not take 2.5 years to get your study going, because how many major academic conferences happen in those 2.5 years, okay? What happens if my study gets out of fashion? You end up with this. These are 6 major of the top 10 cancer centers in America. 29% of the studies they open accrue 0 patients. Nobody. Not a zip. Okay? When I do a talk like this to the clinical trials management group, I said, by the way, what this means is you could take a day and a half a week off and no one would notice. Okay? All those steps to open a trial, 0 accruals, they're all non-value added. They're all wasted. Okay? All that years of effort, taking up everybody's time, it's all wasted. By the way, I also argued it should be a third, and a statistician said, well, we can learn knowledge from one person. I said, okay, fine. What are you going to learn from nobody? Right? That's a problem. All right. By the way, CTEP took real issue with my findings, and I said it was 40%, and they went, no! And they actually did a study, and they said, you know, it's only 26.7% of our trials open with insufficient accruals. Really? A quarter of the stuff you try, you can't even say whether it works or not because you don't have enough accruals to make a decision. This is not to say you failed because you'd have to have enough data to fail. You don't even have that. Right? Example, you're going to quit your soccer game halfway through the second quarter or the second half. You're just going to walk away. That's a lot. That's why the system, that's part of the reason why the system is really expensive. Okay. When I first got into this business, everybody said IRB. And usually they went, IRB. There was colorful words in front of IRB. And they said, it's got to be the IRB. And I said, okay, fine. I don't know. So each of these are individual studies. And the blue is scientific review, the red is PI holding time, the green is ethics. Okay? Whenever I talk to a PI, the PI would go, look, I can show you data. The IRB sat on this thing forever. And I'd go to the PI and I say, Chris, what the hell? And Chris would go, no. Look at that. They sat on it forever. The one I don't understand is why nobody ever talks about it takes a long time in scientific review. As a systems engineer, the problem is the variance. Look at the height of the blues. look at the heights of the greens, which means this is a process out of control because you cannot predict how long it's going to take, which is going to drive an incredibly expensive set of drug development. Okay? You've got to be really careful about that. All right. Make check of a variance. By the way, there's published literature on high variance, high uncertainty, high dissatisfaction. Okay? I'm going to go quickly at this. If you actually simulate, if we work together, we could drop this down to less than a month to get it done quickly. I really like pre-competitive consortiums, which we just talked about, which is fabulous. I'm going to do this really quickly. Pre-competitive consortium. A friend of mine says, you don't get a working cyclotron by funding 1,000 R01s. Right? We got to work together. By the way, you want to know how to change academic performance? Look at how CERN does tenure promotion. Those are people that say we got to work together. I'm going to skip this part. By the way, this is what used to be phone lines until we got to this, the Wi-Fi, now we connect everything. I'm going to pick on you just for really, really quick. This is a great process map. One of the things you can do is you can take all these things and you can do a map and saying, how many projects do we have in each of those boxes? When we did this in manufacturing, we found we had no projects in boxes, which means you couldn't get there from here because you couldn't get through that step. Right? It's a major issue. Last thing I'm going to be really quick. Who are the other two people who won the Nobel Prize in 1945 with Fleming? What were they known for? And this is specifically for you, Chris. They were translational sciences because they figured out how to make penicillin in volume. Fleming discovered it. They figured out how to do translational science and make it. Oh, and that's it. I'll stop. Thank you.